Hey everyone, welcome back from spring break. Back is, of course, in quotation marks because we're in crazy land now. Let's go ahead and start with 12.1, which is Introduction to Double Integrals. Okay, so you know a single integral, with a caveat for y equaling f of x being greater than or equal to 0, okay, has an interpretation as the area under a curve. Okay, well, a double integral with the caveat for z equaling f of xy greater than or equal to 0 can be thought of as the volume under a surface. Okay. So let's say, for example, let's say that we're asked to take the integral, and we'll put a r there for region, of 2 dA. So this dA sort of indicates to us that we're taking a differential area element. For now, we're going to interpret that as dx dy or dy dx. There's a deeper interpretation there, but for now, let's just use that. So, our region that we're given, it's written like this in the book: xy with -1 less than or equal to x less than or equal to 1, and 1 less than or equal to y less than or equal to 6. Okay? You might see me write this, or you might see this written as -1 to 1, cross with a multiplication sign, 1 to 6. Okay? That's another way to write that. So, first thing we're going to do, we're going to write this, we're going to interpret this as a volume. So let's draw our situation here. Now that's as good as it's going to get. So from -1 to 1, that's the x. From 1 to 6, that's the y. So we've got that sort of area that we're going to be integrating over. Our height is 2. So we've got, badly drawn, the volume of this box. Okay? So, if we think of this as a volume of a box, it's going to be height times width times length, which will take our height to be 2. Width, we'll take that to be 2 as well, from the -1 to 1. And the length is going to be 5 from 1 to 6. So that's equal to 20. Okay, so we've got that. Now, we can actually also do this integral. The actual way that we were asked to do it was this way, the way we just did, but let's do this as an integral as well. Okay, so we're going to take the integral. X goes from -1 to 1. y goes from 1 to 6 of 2. And now, I like to write down here y. So this means I'm going to do the integral in y on the inside. So I'm going to put dy there and dx there. I like to think of it as I'm doing the integral like so. So I do this integral first in y. So that's going to be x goes from -1 to 1, 2y, y goes from 1 to 6, and then I have a dx that I'm going to integrate after. Well, 2y, that's just going to be 12 minus 2, so that's going to be from -1 to 1, 10 dx. That's going to simply be 10x from -1 to 1, which gives us 20, like we had before. Okay, I'm going to split these lectures up. So this is the last, I'll start a new lecture in a minute. So go ahead and I'll see you in a bit.